example 6. Okay, so we want to find again the general solution to this non-homogeneous, right? This is our non-homogeneous equation, right? Here's our function of x, right? It's definitely not equal to 0, right? It's a polynomial function. So again, let's use our 3 steps. And on your homework, you'll notice the first few problems ask for the particular solutions. You want to be comfortable finding the particular plus the complementary solution to find the most general solution on your exam. So just make sure you're comfortable doing that. Okay, so find y sub c. So our corresponding homogeneous equation is this guy, right? There's our homogeneous equation, right? It's just equal to 0. And the associated characteristic equation or auxiliary equation is r squared plus 4 equals 0. And if we solve for r, right, this is going to be, using the square root property, this is going to be r equals plus or minus 2i, so definitely an imaginary number. Now remember, this means 0 plus or minus 2i, where remember this guy is, right, our a, and this is our b, right? Remember, a plus bi is a complex number where a and b are real numbers. So we have by theorem 3, so by theorem 3, right, from in section 2.3, so on page 131, if you want to go ahead and look at that, or if you remember it, the way we write our general solution, the form is, okay, we know that's y sub c, and that's going to be, let me go ahead and just write it out, since it's a good review for your test. C1 cosine bx plus C2 sine of bx. So all we want to do is input our a and b, right? So we want to input that guy, and we have our a and b. So this is just going to be, well, this is nice. This is e to the, well, 0 times x is 0. That's just going to be 1. C1 cosine of 2x plus C2 sine of 2x, right? This is just a big 1. So here is our complementary function. So C1 cosine 2x plus C2 sine 2x. Okay, so here is, and actually I think I was boxing it yellow. Okay, so there's our y sub c. So now let's construct a particular solution. So number 2, right, let's construct y sub p, right, that is not going to be contained in this guy, right, because we don't want to duplicate things, or, I mean, again, we don't want to add anything that's already there. So let's see, we have our y sub p. When we choose our y sub p, well, what's the form? Well, this is a polynomial function, right? 3x to the third, or ax to the n. So we're definitely going to use that to choose. So construct, so let or choose. So let y sub p, right, be of a polynomial form, right, of third degree. So we know it's going to be ax to the third, right, and the next term, right, is bx squared plus cx plus d. So again, I started with x cubed because my degree here is cubed. If that was a fourth, I would do ax to the fourth plus bx to the third, and so forth. So there's our polynomial, and we can differentiate this guy. So we get, let me make this a little bit bigger. Whoops. So y prime, well, this is a nice polynomial, so it's just 3ax squared plus 2bx plus c, and y double prime is, that's a 6ax plus 2b. So now let's go ahead and substitute these expressions back into our NHE. So again, maybe want to write all these guys. We're going to substitute, right, sub back. Okay, so let's do this carefully. So we have y double prime. Well, it's right there. So 6a x plus 2b and plus 4y, so plus 4, and then my y is this guy. So 4 times all of that. So I'm going to go ahead and just distribute the 4, because that's what you're really doing, right? I'm multiplying this by 4. So 4ax cubed plus 4bx squared plus 4cx plus 4d. And all of that is equal to 3x cubed. Okay, so again, the goal is we want to, at this point, is we want to equate coefficients of like powers in this case, because we're working with polynomials. So let's see, what can we combine? Let's see, we have, well, that's, whoops, that's the only x cubed. So that is, okay, I'm just going to leave that there. Let me make this a little bit thinner, my pen, so I can fit all of this. X squared, well, that's the only x squared. So 4bx squared. And then x's. So x's, and I think that's it. So plus 6a plus 4cx. And then finally my constants, right? These have no x's. So that's just 2b plus 4d. And again, that's all equal to 3x cubed. Okay, so let's equate some coefficients. So remember, this 3x cubed is really, all right, there's a plus, right, 0x squared plus 0x, you know, plus some constant 0, right? I mean, that's all 0. We don't write it out, but that's 0. So maybe that, I wanted to write that out if that helps equate these coefficients. Okay, sorry, I write really big. Okay, so we have, let's, I don't know, use green here, light green. So I have 4ax cubed and 3x cubed. Well, if, again, if all of this is supposed to be equal to all of this, right, that's a polynomial equals a polynomial, then these guys should be equal. So we definitely have 4a is equal to 3. And what else do we have? We have this 4b, and well, that's x squared, and then we have 0x squared. So that's definitely 4b equals 0. And again, that's a coefficient times x, a coefficient times x. And so we have 6, not 6, 4, that's 6a. 6a plus 4c equals 0. And then again, the constant is just equal to 0, so 2b plus 4d equals 0, and so we can make this system a little bit bigger. Right, so these are the relationships that we obtain by equating coefficients of like powers of x. And this is nice because this guy, right, if we solve for a, it's just 3/4, and b is nice. B is just 0, right? 4 times 0 is 0, so b must be 0. So we have a, b. We can definitely find c, right, by substituting our a here. So it's just, this is just algebra. So we have 6 times a plus 4c. Well, we have 18 over 4 plus 4c. I'm gonna subtract both sides by 18 over, 18 fourths, right? But we know if we reduce this guy, this is just 9 halves, right? That's just a big one. I can divide it by 2. So 4c. And again, just some algebra. I can multiply by a fourth because I want this to be a 1. And so I get 1c, or c equals negative 9 over 8. So, so far I found a, b, and c, right? Here's a, here's b, here's c. And all I need is d, and I can definitely find d. I have a relationship here between b and d. So 2b, well, this is great because 2 times 0, so this works out nicely. So then d is definitely 0. Okay, so I found a, b, c, and d. So now we can rewrite our yp, right, or yp of x. Well, what did I call yp of x? Well, my yp was right here, right? My ax cubed plus bx squared plus cx plus d. So I'm just going to rewrite that. Ax cubed plus bx squared plus cx plus d. And let's just insert what we have. Well, we know d is 0. I think b was also 0, so that's gone. A was, where was a? 3/4. So 3/4 x cubed plus, well, it's plus 9/8, negative 9/8, so it's just negative 9/8 x, right? I'm just inserting my a and c. So here's my yp. So now let's add these together. Let's put them side by side. So remember, my y sub c was our cosine and sine, right? C1 from our characteristic equation. So let's see, cosine 2x. Okay, so final solution is a C1 cosine 2x plus C2 sine 2x. And then I'm going to add my particular solution, if you want to maybe write parentheses or not. And right, our choice was, I mean, it worked also because we didn't get a false statement, but this guy, right, this polynomial, it doesn't live in this expression. So there's no, I mean, we are actually adding something new here. If our y sub p involved, you know, cosine 2x, then we probably would have multiplied our yp times x, like I did in the last example. So this is, again, your final solution. Here's your yc and yp.